All right, so this is the module on fossil fuels and renewable energy. And in this video, I'm going to teach you how to calculate the number of solar panels needed for a building based on electricity usage, peak sunlight hours, and panel wattage. So I'm going to use the example of my own household. So in my household, we use approximately 150 kilowatt hours of electricity each month based on our most recent electricity bill. And that comes out to about 5 kilowatt hours each day. So if I go to the National Solar Radiation Database, I can determine the peak sunlight hours for my particular region. All right, so the first thing I'll click on is the NSRDB viewer. That'll bring up a page that looks kind of like this. You want to make sure that you select global horizontal irradiance and make sure that checkbox is checked. You can turn off some of the other layers, really doesn't matter. Some of the layers refer to other regions of the world anyway, so they're not relevant for my example since I'm using my household. So anyways, next step is you kind of zoom into your region. Once you have this layer turned on, zoom into your region, then click on the region to find the average GHI, which for me is about 5.4. And to understand what the units of that are, you click on the legend and you could see that the GHI is measured in kilowatt hours per square meter per day. All right, so that's 5.4 for my case. So now that I have the GHI value for my region, peak sunlight hours is basically equal to the GHI value divided by 1,000 watts per square meter, which is the strength of the sunlight when it's more or less directly overhead. So if I take my value 5.4 kilowatt hours per square meter per day, I want to convert that to watt hours so that the units cancel out appropriately. So 5.4 kilowatt hours is equal to 5,400 watt hours. So I take that value 5,400 divided by 1,000 watts per square meter, which gives me a value of 5.4 hours per day. And you can see that the watts and the square meters cancel out, leaving me with just hours per day, right? So in my region, I have peak sunlight for about 5.4 hours each day. So if I take my electricity demand, 5 kilowatt hours per day, divide that by 5.4 hours per day of peak sunlight, that gives me 926, 925 approximately watts. Right, so I want to add a safety factor onto that. So I multiply it by 1.25 in order to account for seasonal variations in radiation and decreases in panel efficiency over time. Right, so that gives me a design value of 1,445 watts. Next step is to choose my panel. So I'm gonna assume that I'm going to use a panel that has a capacity of 250 watts. So I take that total value that's required, 1,445 watts, divided by 250 watts per panel. That comes out to a little bit less than 6, but I'm going to round up to 6 panels. All right, so for my household, I would need to purchase 6 panels that have a capacity rating of 250 watts per panel.